Okay, so now we're going to take a look at how changing volume or changing pressure of a system or a reaction at equilibrium affects how the reaction will shift. So if you remember, we learned Boyle's law in January. And Boyle's law, which the formula, just to remind you, is PV1 equals PV2. Okay? And we learned that if the volume of the container increases, the pressure decreases, because that means the container is bigger and the molecules are hitting the wall less. Conversely, if the volume of the container decreases, and this is again assuming that the container is rigid, then the pieces, because the container is smaller and the molecules are going to hit the wall of the container more. So, if the pressure is increased on a system at equilibrium, the shift towards the side of the reaction that has less moles of gas. And the reason is why. So why is the reason why? Well, if you shift towards the side with less moles of gas, that lowers the pressure, because less molecules are hitting the wall. And I need to go back because I'm an idiot. And so if you increase the pressure by shifting toward the side of the reaction with less moles of gas, you're lowering the pressure back to what it was. Conversely, if you decrease the pressure, you're going to shift towards the side towards more moles of gas, so that you can go back to what the pressure was at equilibrium. Okay? So, if you increase or decrease the pressure and the moles of gas are equal on each side, and we only care about moles of gas, not solids or liquids, they don't create pressure, or enough pressure to matter, then no shift occurs. So if there's equal amounts of reactants and products on each side, and you change the pressure or the volume, no shift occurs. So this one says here, which way will the reaction above shift, it should say, if the volume is increased? Well, if you increase the volume, you have to think, okay, well, if I increase the volume, what am I doing to the pressure? Well, the container is getting bigger, so that means they're going to hit the gas molecules are going to hit the wall less. Oh, sorry, guys. Reverse. Are going to hit the wall less, so you're lowering the pressure. The container is bigger, so the gas molecules, and I hate when it goes forward. So, again, you're making the container bigger, so the gas molecules hit the walls less, so you lower the pressure. And in order to increase the pressure, it's going to shift towards the side. The reaction is going to shift towards the side that has more gas particles. So let me get a different color out, which I'm struggling with. So again, we lower the pressure, so we want to shift towards the side that has more gas particles to raise the pressure. So this side has 4 gas particles, 1 from nitrogen and 3 from hydrogen, and this one only has 2. So again, to increase the pressure, we're going to shift towards the side that has more gas particles to increase the pressure. So in this case, we're going to shift to the left. And the reason why is more gas particles. And I hate when it does this. More gas particles. So more gas particles will increase the pressure. And return it back to it was at equilibrium. Now, if we look at the system at the bottom, which way will the reaction above shift? There should be the word shift if the volume is decreased. So if you decrease the volume, that means you increase the pressure. So then we want to shift towards the side that has less moles of gas. So here again we shifted to the right. This was to the right. But here we're increasing, where the volume is decreased, so we're increasing the pressure. So we want to shift towards the side that has less moles of gas, and this side has 1 mole of gas. This side has 0 moles of gas. So again, in this side, we want to shift to where there's more to increase the pressure. So we're going to shift in this direction. Actually, this was to the left. I'm an idiot. So we're going to shift towards the right. Again, because this has no gas particles. So that will decrease the pressure back to equilibrium. So again, what's the summary? If you lower the pressure, you want to shift towards, this is sort of like the big idea, okay? If you lower the pressure, you want to shift towards the side that has more gas particles to increase the pressure. So I would write that down. If you need to rewind, rewind. If you raise the pressure, you want to shift to the side that has less moles of gas to lower the pressure back. And I guess I can write that, or if you're done, you can just say. So I'm actually going to get out of PowerPoint for a second and write this someplace else. Hold on. Alright, so just to summarize this, I went to OneNote. So if you increase the pressure on the system, which is the same as decreasing the volume, okay, you're going to shift toward side of the reaction with less moles of gas to decrease the pressure back to the equilibrium pressure, which will decrease the pressure. Now, if you decrease the pressure when the system is at equilibrium, that's the same as increasing the volume. You're going to shift toward the side with more moles of gas, which will increase the pressure, which we want to bring it back to equilibrium. To bring back to equilibrium. Alright, I am now going to get my vaccine, and I will make the last and final video.